Hi guys, in this video we will discuss about histogram. We have imported these libraries and we have written a small function to generate a graph that depicts frequency count of each and every unique values in the data set passed to this function. So we are generating numbers between 1 and 10, and the number of numbers generated is 10. And let us invoke this function by passing this data set as an argument. So let us invoke this. Okay, good. So what is going on here? This is the data set and this is the frequency count. 1 is occurring once. So x-axis is talking about each and every discrete value present in this data set. In fact, present in this range. Then the y-axis will show us the frequency of that discrete value. Say for 1 is a discrete value. This one is what? Frequency count. Again for 2, this is 2 discrete value. Frequency count is again 1 because there is only 1, 2. There is no 3 here. It is blank. 4. There are 2 4s. 1, 2. Hence, y-axis 2 and discrete value 4. 5, no 5, hence it is blank. So on so forth. Good. Let us create another data set, and this time we will say, okay, 1 to 20, that is the range, and let us create, no problem, we can create 100 such numbers. Okay, so minimum is 1, maximum is 20, fine. For all these numbers which is mentioned in this x-axis, frequency count is being depicted. Very good. Let us create another set. This time we will say we want numbers from 1 to 50 and maybe 100 such numbers. Okay. Now observe. The thickness of bar is getting reduced. Why? Simply to accommodate the number of numbers involved. Here there were 20 numbers. Here there are 50 numbers. So matplotlib is adjusting the thickness so that all the numbers can be depicted. Okay, good. Let us this time generate 100 numbers and the range being 1 to 100. And just see, okay, we can also write 500, no problem. Look, here single digit, we can read all discrete values clearly. Here it is still okay. Gap is there between two distinct numbers. But look at here, 99 and 100. They got completely merged. There's no space to keep them apart. Fine, but still frequency count is happening and we can read, and there is no problem with respect to the number of numbers because frequency count y-axis will get adjusted and we can do that. The problem will start occurring here. Where? In the x-axis. Let us see that. This time we are going to generate maybe 500 numbers, the range being 1 to 200. What does this mean? This means that 1 to 200, all this number should be written in x-axis, right? But what will system do? System will write. It will start writing like this, complete overlapping. We can read this 1, 2, 3, 4, 5, 6 fine, but what about these numbers? Numbers are getting overlapped. Hence, we cannot really make out a particular bar belongs to which number. Correct? Now, see, we will not have only 200 distinct number. Well, we can even have 1000 distinct numbers, 1 to 1000. Now what will happen? There will be more overlapping and the darkness of this black color will get more intense now. Let us wait and see. So system is trying to write all numbers, right, 1 to 1000 within this space, and it won't be able to write, and it will also show frequency count which will be completely mixed up. See all this number, what happened? So 1 to 1000. See, look at this x-axis and these bars. They are so close. We cannot read the values in x-axis. Hence, no matter what it is, it makes no sense because we cannot correlate. How to get rid of this problem? Because we can have such numbers, right? The solution to this problem is only one. When we have very large number of numbers, rather than taking frequency count of each and every discrete value, we will take frequency count of ranges. We will say from this number to this number, these many numbers are there. This number to this number, these many numbers are there. So what we will do? Let us for this create such graph. Such graph is called histogram. And we'll write X and we say 10. What does this 10 means? We are creating 10, 10 ranges we are creating. So for every range, we will count. Just see here, 10 ranges have been created. How we can think that it is 10 range? See, from here to here, from here to here. So let us store this in a variable and then count. We will store in x1. And what is x1? Let us discuss about x1 first. X1 has got two elements. First element is talking about for counts for each and every range. See, 53 means the range 2 to 117 has got 53 numbers. That is what it's talking. And how we can count how many ranges? So let us talk about x1's second element. So this is range. How many are there? How many numbers are there? 11 numbers. Why 11 numbers? Look, if we have to have 10 ranges, we have to have 11 numbers, isn't it? See, from this to this, 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 like this. So we have to have 11 numbers to create 10 ranges. That is good. Now here, what is this? 2 to 101.7, 53. 101.7 to 201.4, 43. So on so forth, the counts have been created. Now, the most pertinent question that should be asked is, why these decimal numbers? Why are we getting these decimal numbers? We are talking about discrete values, right? These are all discrete, 1 to 1000. They are discrete values. From where these decimal numbers are coming? Look, the answer to this question is, what is the minimum number that got generated? 2. What is the maximum number that got generated? 999. See, there is no 1 and 1000. System did not generate 1 and 9. So let us check that first. Okay. What is the minimum number of x? 2. What is the maximum number of x? There is no 1000, there is no 1. Because it is random, it is skipped 1 and it is skipped 1000 also. That is fine. But how we are getting decimal? See what we said, we need 10 buckets, we need 10 bins. So this is how it has been derived. Max x that is 999 minus min x, okay, divided by 10. 99.7. So what is happening here? First is 2, add 99.7 and you will reach 101.7. To 1.1 to 101.7 add 99.7, we will reach 201.4. Like that, we will go till 999. In other words, starting from minimum number, if we keep jumping 99.7, we will reach 999 after having jumped 10 times, which means if we are jumping 10 times, there has to be 11 numbers. See, first jump, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10 jump. But how many numbers? Numbers are 11. See here, we already counted. Okay, this will be clearer now. We will this time create 11 buckets. Then what will happen? Let me push this down. Okay. This time what will say? Create 11 buckets. Wow. Now we'll see what is happening in this X1. If we are creating 11 bins, how many numbers should be there? Let us check this one. Take length. It will be 12. Correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, another thing. This time again we'll say max x min x. Correct? Divided. So, max x minus min x divided by this time 11. What we are getting? 90.63. To add 2 plus 90.663. What we are going to get? 92.63. And we will add 90, 92, right? Okay. To 92.63, we will add 90.63. What we are going to get? 183.26. Look, 183.2. We are getting 6. What is that? Okay. This is, we have to write 90 point. Maybe we can write like this. Okay. Okay. So this is the number we are going to get. So this is how histogram is creating bins for us. And when it is creating bins for us, due to this calculation, decimal numbers are coming in the picture. Though there are no decimal numbers, there are no continuous numbers involved in our data set. That is fine. Absolutely no issue. What system will do? It will say, hey, let us count how many numbers are there between 2 and 92.63. So it has counted, it has given, it is telling there are 45 such numbers. How many numbers are there from 90.63, 92.63 to 183.27? 41. Of course, there will be some adjustment of greater than, equal to, or less than equal to signs that we will certainly discuss when we will see how this histogram can be created by us rather than generating through this PLT hist. We will create our own bins through custom coding, and we will count and we will generate like this. So basically, we will try to understand the logic behind histogram. Thank you for watching, and I will see you in the upcoming video.